Hey, good afternoon and welcome to today's Power Hour. Here we are already, it's August. Can't believe it, and it's hot. I'm here in Texas at our studio. It's a hot day outside. We got the AC cranked here. It's hot. But we're not talking about air conditioning, we're talking about ignition coil diagnosis today. So through our series in the past couple of years, we've had various sessions on ignition coil diagnosis. I always encourage you to go back to our Standard Brand YouTube channel. You can see our Power Hour playlist. You can rewatch some of those ones there today. But today I'm going to be talking about solely ignition coil diagnosis. So I'm going to talk a little bit about how they work. We'll kind of talk about Coil-on-Plug, because that's where we're kind of at today. No sense talking about HEI, even though many of us grew up with that. I'm going to give you a little bit of a throwback. We'll look at some ignition patterns, and we're going to apply it to a modern vehicle. I've got a 2015 Chrysler 200 here in the shop. We'll look at some scan data. We're going to look at a couple different testing methods on this particular vehicle. So let me slide over to the bench and let's get the program started. Okay, so as mentioned, we've seen a ton of different iterations of ignition coils throughout the year. Remember the old canister ignition coils? Hey, maybe some of you even worked on the old wooden box coils back in the day. My career started working on like the old Ford 8N tractors with a canister style ignition coil full of oil there. We've gone from HEI to DIS, coil near plug, and then we've got coil-on-plug ignition here. So as we look at the system here, we can see this is a typical 3-wire ignition coil. I'll talk about the difference on some of those with 3 and 4 wire here. But let's kind of review how the ignition coil itself operates. So I've got some different ignition coils on the bench here. And so I've actually got a few cutaway components here. So I've got a primary and secondary windings here. And so as we look at them on the screen here, let's kind of take a look at what's going on here. So the main components are the primary and secondary windings, which are going to be wrapped around an iron core. Now the primary winding is much thicker than the secondary, but there's a lot less loops of wire here. And so now a switched external circuit is used to supply current flow through this. So we see on the lower left there, we've got our made up circuit here, and we've got that ground, and you can see right now it's not providing a path to ground. So once that is going to be closed, now the primary is going to turn on. And so now we're going to see a magnetic field generated around the winding. So as this magnetic field expands, a counter voltage will be created into the primary, and that's going to oppose the flow of the current. This expanding magnetic field is also going to generate a voltage into the secondary winding there. And because of all the additional loops here, so again, if we look at my samples on the bench, we've got the primary, this little heavier wire, and we've got a much finer wire here on the secondary with significantly more windings here. That's going to significantly amplify this here. And so right now, again, I ask you to pay special attention to the polarities here. So in the primary, we've got positive on the top, negative on the bottom, and the secondary is opposite of that. So now the trigger or the control portion or the driver is going to turn off here, and now we create spark. You notice how those polarities have reversed themselves here at this point. And now this magnetic field is collapsing upon itself here, and it's sending all the current out to the spark plug to ionize or jump across the gap there. So that's when spark is created. Now keep in mind, different conditions are going to require different type of spark demand. So when a vehicle's sitting in the bay, like the car is sitting here right now, imagine if it's idling, it's not going to take a whole lot of work here. We've got low in-cylinder pressures at that point. We've probably got a good air-fuel mixture now. And so keep in mind, the fuel atoms are going to help jump the gap there, help that spark travel. It's going to create a path of connectivity there. But now if we're taking it out under hard acceleration, we've got increased in-cylinder pressure. We've got significant spark advance happening here. A lot of different conditions, maybe even a lean condition where we don't really have that fuel atomization across the spark plug gaps. It's going to require significantly more work. And so if this coil is weak in any way, it's going to result in a misfire there. Or, I guess it'd be nice if a coil worked or didn't work, but in our world, reality says it's an intermittent or random misfire, usually before it becomes a complete failed ignition coil. So at this point, it's jumped the gap, the circuit is going to be open, and now it's going to start that routine all over again. And this is going to happen many times per second. So when you keep that in mind, there's a lot going on here, a lot of current flowing through these things, a lot of electronics going back and forth. And so, when you stop and think about it that way, it's really a miracle that this stuff occurs. There's a lot happening here. And so that's why it's important to have precision-made ignition coils here and precise operating conditions. So let's look at some of today's coil-on-plug systems and really kind of break them into two different categories here. Where's the command signal coming from? Who's doing the actual work here, telling it turn on, turn off? And so the first one's going to be an ignition coil with a driver in the PCM. The second one we're going to be talking about is where the driver is actually in the ignition coil itself. So on probably one of the most popular selling ignition coils, let's say the Ford 2-wire ignition coil, even this Chrysler here, we've got a 2-wire ignition coil. And so you can see kind of the typical schematic shown on the screen here, where we've got B+ ignition power being fed to the primary side of the ignition coil. And then the PCM is going to command the ground side of it there. So that's where the actual driving of this circuit is going to occur. The switching, if you will occur inside the PCM. So we can see our primary circuit, and then we can see our secondary circuit connected directly to the spark plug itself. So this is fine and dandy until either the driver goes bad or the coil shorts out. And in that case, the driver is going to go bad. So maybe you've run into this. I've personally run into this many times in the shop. I even run into it with my own kid's car, a Ford Fusion, where a faulty ignition coil took out the driver in the PCM. And so that's one of these tips here is if you run into this situation, we don't want somebody to just go, oh, it's got a bad coil, put in a new coil. Well, if you got a faulty driver, great chance of damaging that new coil. So you always need to stop and verify the control signal before installing the new coil. A lot of people like to just, well, let me swap cylinders 2 and 3 around. Well, you may just kill that particular one as well. So always stop and verify that the signals are what they need to be. Once you've come to the diagnostic conclusion, like in my scenario, we've got a faulty PCM now because of, what came first, the chicken or the egg? Is it the coil killed the driver in the PCM or the PCM killed the coil? Regardless, in that situation, in my world, it gets 6 new ignition coils and a new PCM. And so that's where there's that little tip here as well. You want to make sure that you don't have coils plugged in when you're going to exhale and inhale the PCM information or that as-built information on a Ford when you're programming that new PCM. If you plug it in, the new PCM, and you still have the shorted coils installed on the vehicle, you're going to burn out that new PCM again. So either have your new coils installed or go ahead and unplug them all when you do this process here. So now in those vehicles that have the driver in the coil themselves, that's typically going to be our 3 or 4-wire ignition coil. So you can see the schematic here. We've got a 3-wire ignition coil. So in the upper right there, you see the battery junction box, also known as the fuse panel in many vehicles. And so this is going to be where the B+ power comes to the ignition coil. So we've got constant battery feed there. Then you'll notice it's got a dedicated ground. That's going to be the 3rd wire there. But then the middle wire will be our trigger wire coming from the PCM. And so the PCM, unlike where it was on the other ones, and it's actually physically making the connection there and providing the ground, this one is simply sending a square wave trigger signal there, telling, if you will, the ignition module inside of that PCM to turn on and do the work. So if you think back to the old distributor days where we had an ignition module, or even DIS days where we had a separate ignition module, think about now that module being inside of each ignition coil here. And so we've just got a trigger signal coming to it from the PCM itself. and then it's going to turn on and do the work there. In those cases where you might have a 4-wire ignition coil, here's a typical one from a GM. This is off a 3.6 liter, very popular application. And so again, you can see we've got dedicated ground inside the PCM. We've got an external ground. We've got the B+ feed, and then we've also got the trigger signal there, basically telling the ignition coil to turn on, turn off. It's not doing the actual work, it's just sending a command signal to it. The work's occurring inside of the ignition coil there itself, and now it's doing the work there. So if you're working on a Toyota, that might be a little different one. That's got a command and feedback signal there. You know, so I don't want to say they're all 4-wire like this, but we always recommend to do your research, look at a wire schematic there. But you should get a good understanding here, or a little bit of a appreciation for the differentiation between the two different ones here. So now we're done talking about different types of coils. Let's kind of jump into some of the tools of the trade, some of the stuff we use for diagnosing here. And so it can go different ways. You know, I've seen technicians, or I've worked with technicians who are much more robust than I am, let's say, or manly, and they will actually put their hands over a plug wire and feel for a tickle. Not this guy. I'm way too scared of electricity. I've gotten hit enough times. I'm not touching an ignition system, nor do I recommend it. So, you know, on older ignition systems, I might take like my test light and spray it down with a water bottle and, you know, run my fingers along it. Might even do that with some of the newer ignition coils. You know, if we've got a boot jumping to the cylinder head or something at some point, that's a good way to determine if we've got a secondary leak at that point. Really, one of my favorite tools is this little guy here, where you can just simply clip it to ground and slide to the ignition coil there. And it's got a huge gap, and so this is going to max out that coil. 9 times out of 10, I'd even say 99 times out of 100, if it can jump this gap here, it's going to be a coil with a good output there. Now, there's a ton of different testers out there. There's some of them here. You know, we've got one here in the studio or in the shop where you can actually adjust it. I don't mind this one either. You can ground it, you can adjust it, you plug it onto the coil there, and you can observe the spark that occurs there. And again, you can adjust it, test your variable outputs there. There's other ones such as this that kind of go in line there. I'm not personally a huge fan of this, simply because it's difficult to get them to clip on, lock on properly. I don't know what the specification is on this particular unit here. And so it might flash, we might indicate a good spark there, but I don't know if that's really truly stressing the ignition coil out. Here's something that's come on the market a little more recently. And so, you know, we always got to try it, kind of in the name of Mythbusters. So there's these devices where you turn on and it detects a magnetic coil. And so, see, there's one of the issues right there. Just by going around this, it actually beeped and indicated. So the thought behind like this pen is that you would hold it over the coil. If there's a signal there, it's going to flash. Well, I need to know a little bit more than that. Sometimes if we're really looking for direction, fantastic. It might give us some direction there. But I prefer to use a lab scope or a scan tool, right? So when does the customer bring in the car and we're trying to diagnose an ignition coil? Typically, it's going to be because of a misfire concern or a no start condition. And so if we got a misfire, hopefully at that point, we're able to hone in on one specific ignition coil at that point. And so then we can do our different tests there. In a second, I'm going to go to a lab scope, and we're going to do a multitude of different tests with a lab scope. So again, I understand not everybody has a lab scope, and not always do I need to pull my lab scope out. Quite often, again, I'm going to go to this guy. If I've got my specific cylinder and I know where my problem coil is suspected, I'm going to insert this, and we're going to test it, make sure it can actually jump across here, that we've got good spark. And if we don't, now I need to verify the signal there. Is it a 3-wire, 4-wire, 2-wire? What type of signals am I going to be analyzing there? So let's get into a little bit of this ignition waveform refreshers here. So I grew up in the days with the old Allen big box scope, right? It was bigger than these toolboxes behind me here. It was a huge deal, significant investment on the part of the shop at the time. Wondered how we're ever going to pay for it, but very quickly it became our eyes into the vehicle. By looking at ignition waveforms in those days, we could determine a ton. Remember, back in these days, actually, it was before we had a lot of scan data. You know, we may have been using the key underneath the dash to flash codes. Some of the early GMs, we may have had a little bit of scan data, but not a ton. And so we had to learn secondary waveform patterns here. So let's kind of review here. So as we look at the image on the screen, we can see point A is where the ignition primary is turned on. So prior to that, we've got 12 volts on the screen. Now at point A, the trigger is going to, or the driver is going to pull that almost down to zero. Not all the way to zero, but it's going to turn it on. And so at that point, we're charging the primary. And so you can see the duration there, all the way up to B. That's when that primary is going to be turned off. And so at that point, remember, we're releasing that voltage. It's going to collapse the magnetic field, and we're going to send that voltage out to the ignition coil. And so that's where we see C is going to be our peak voltage there. And so we've got 100 kV exhaust of ignition voltage. And now when we get to point D, that's going to be our spark line. This is what's going to be happening inside the cylinder. So as it's jumping from one electrode to the other electrode at that point, that's what's happening inside the cylinder. Now, if you look here, this is really a pretty good one. It's actually tapering down a little bit. So as burning off the fuel mixture in there, we can see it's tapering down. We get that little bit of a tail at the end there when it turns off at E. And then we can see the coil oscillations as beginning to recharge itself and prepare to happen all over again here. So that was great in the days where we had accessible secondary ignition. We could clamp onto a spark plug wire, you know, get it right at the distributor cap. But with Coil-on-Plug, we really don't have that same access. Or do we? Well, I'm going to tell you here, and maybe even just remind you, everything that happens in the secondary happens in the primary. So in this example here, we're using a lab scope and we're back probing Coil-on-Plug and we're looking at the primary side here. And so if you take a look at this, you can see really the exact same thing occurring as what we saw when we were looking at secondary previously. And so we can see the primary get turned on, we can see it get turned off, you can see the peak voltage there, and then you can see the spark line in cylinder as it's kind of tapering itself down there, burning off that air fuel mixture. It puts itself out. We can see the coil oscillations as it starts the circuit all over again. And then we can also look at current. So using our low amp current probe, we can actually, we can either put this over the primary feed to each individual coil. I'm going to show you a little different trick here, one I learned years ago to make things more efficient on a complete ignition system diagnosis, where we're going to watch all of them here. And so if we take a look at this one, we can notice that when the coil primary is turned on, the current is going to start going up. And so we can see that nice smooth ramp there, and we can see some oscillations at the beginning, and now it's going to build. And now we're going to see where this goes up to about 8.5 amps is what it's pulling there. And then it's going to have a nice clean turnoff, and you notice the tails or the oscillations there at that shutoff. So this is an example of a good ignition coil. Now, if we've got a faulty ignition coil, take a look at this one here. That turn on, we don't really get that ramp. It goes vertical there, and that's usually due to some sort of an internal short or bypassing some of the primary windings there. And so we've got a problem with this particular ignition coil. And again, it's where it turns on there. And then we've got kind of the rest of the ramp looks pretty decent. Now, obviously this isn't drawing as much amperage as we had previously. So it's about 1 amp less here, or 2 amps less. And then notice the turnoff. It doesn't sharply turn off. It kind of tails off at the end there. So again, this is indicative of a faulty ignition coil current pattern. So hopefully after that little bit of review, let's actually go to the car here. I'm going to fire it up. I've got the scan tool hooked up. We're going to see what's available on scan data on this particular vehicle, because some vehicles we do get a primary spark output data PID or a spark duration data PID. You know, we can get some information. I've got the information pulled up on this car. Let's kind of take a look at this together. And then I've got the lab scope set up here behind me. And so we're going to look at the primary circuit, and we're also going to look at the ignition current. I've also got a little paddle probe there, which some technicians really appreciate. I haven't spent a whole lot of time with it, but it's a tool nonetheless. And so let's jump into this a minute. All right, well, let's get the car started here a minute. Kind of reach in, get it fired up. So we can take a look at, you know, as I mentioned, there wasn't a ton of beneficial data. I mean, obviously we're using engine speed for reference here. It shows us knock retard, shows what our base spark is here, and where our spark advance is. So I'm not getting a ton of diagnostic data out of this at the moment. And so, you know, this is great, but like I said, it's worth looking at. You know, I can click down here, pull up misfire data, and probably pull up some additional data PIDs here, but this is mostly related to the misfire itself. Doesn't give me a whole lot of specific ignition information at this point. So it's always worth looking at. You know, you're going to be in the driver's seat. You'll have it plugged in. It's quick and easy. But let's go now under the hood and do a couple additional tests. All right, so let's go turn around over to the car here. And let's do a little bit of actual physical testing here. So yes, I've gone ahead and loosened up the bolt, you know, in preparation for this. And I'm going to pull out number 1 coil here. And so just like that, I'm going to take the spark tester I had previously, and I'm going to insert it in number 1. I'm going to clip it onto a ground. Now, if you're like myself, you've already stretched that many times. I'm going to start the vehicle up here a second, and we should hear some audible sparking occur. Yeah, so now we've got a misfire in the vehicle. We can hear spark occurring, but we've got good output from that coil. And so I feel like this is a good output coil. All right, so you've seen the spark tester in action here. You know, we feel like we've got a good performing, good output from this ignition coil. So now I'm gonna put it back together. I'm gonna slide it back in. But before I do that, I'm going to take channel A of my lab scope, and I'm gonna back probe the feed circuit here. So we're gonna be scoping the primary. So let me reinstall this here, make sure I've got the bolt put in place properly. Okay, so I've got that in there, set that off to the side. And all right, Corey, we can go ahead and start the car, please. So right now we can already see my ignition primary signal occurring here. And again, without zooming in too closely on it right now, we can see the primary turn on, we can see the peak voltage, we can see the in cylinder occurring here, and we can see the turn off oscillations. I can zoom in, I can look at it significantly more details there. But I've also got on channel B, the red channel here, this little paddle probe. And this is something a lot of technicians use. I don't have a ton of experience with it, but you can see right on here, it says this side to coil. And so I'm simply gonna lay it on top of the ignition coil. And so we can see on channel B that I've got something going on there. So let me turn off channel A. So we're only looking at channel B. And we've got a signal. I move over to number 2 cylinder. I can sneak over to number 3. You know, some of these are difficult to get at, and so that's kind of the beauty of this. I'm not going to be doing any analyzing off the signal. Now, there's probably people way smarter than me that can do that. Right now, though, I kind of like it because it's telling me that there's some sort of a signal going on there. And so it's somewhat beneficial there. I still prefer to actually see my ignition primary signal there. So I'm going to turn channel A back on as it was. Let me turn off channel B. Now I'm going to turn on channel C. And so if we look over here, we can see that I've already done some research, and we recognize that all the ignition coils are fed off of fuse 15. So by removing that fuse and installing this jumper lead, now this one actually has a spot where I can install my fuse again. So I've got my 20 amp fuse in there, and now I'm monitoring the current with my current probe here. So as we look at the pattern on the scope screen, we can see this being synced to number 1. I now know that this is number 1 current from that ignition coil. Now if we apply the firing order and assume it's 1342, we can identify each individual coil. Now I've really appreciated this on some older vehicles like an old V10 where I didn't have good misfire information. By syncing to number 1 cylinder and applying the firing order, and see I've got enough time on my screen here. I'm at 20 milliseconds per division. We could zoom out, we could zoom in, but I've got one complete rotation, right? It's going through all 4 cylinders and it's repeating itself here again. And so now I've got a good understanding of the complete ignition system. And now I can move, if I suspect a coil, I can go directly to that primary circuit. So if we wanted to, we can even go further and slide this over. And so that's, you can kind of see here how we can understand where some of that goes. So if I want to just zoom in on this area right here, we can see, and I'll pause it, we can see how our primary is turned on the voltage side right there. So we've gone from B+, we're getting it pulled really close to ground right here, and it's being released. At that same time, we can see our current ramping up, and it's being released here. So again, that's what I think is so awesome. By observing the voltage, we can see the command signals, but we can also see the work occurring here. And so it's just very indicative of what's going on. Again, as we're zoomed in here, I can see the firing line, what's happening inside the cylinder. We've got great coil oscillation. I really feel good about the ignition system on this particular vehicle. So even if you're not a scope guy, hopefully this gives you a little more incentive to maybe think about one. I'm not trying to sell any lab scopes here, but hopefully now you have a new appreciation for just how much information we can get on this ignition system by utilizing a lab scope. Different tools, and again, the best tool is the one that's in your toolbox, but something to keep in mind. All right, Corey, we can kill the vehicle, and let's wrap this up. Okay, well, hopefully you can see how we can use the lab scope to really hone in on a lot of our diagnosis there. Again, we can use our spark tester like you saw. That tells us if we've got good spark or not. But if we don't have good spark, we need to understand what type of signal is coming to that ignition coil. There's not a whole lot of better ways than a lab scope. And so if you're not into it yet, hopefully you have a new appreciation for it. If it's been a while, I encourage you to dust it off. Spend some time this weekend. Hopefully it's not too hot in your shop. As you can tell, I'm breaking out a sweat here. That's a bad day in my world here. And so, hopefully you've learned a little bit more about this. So Corey, I see a couple questions have come in. We may have answered a couple of them, but yeah, what are some of your favorites?
We got actually quite a few here, Ryan. So you went over quite a few different pieces of equipment there. The question that came through, is there one piece of equipment or tester better than the other?
Well, quite often the tester that you have in your box is the best one, right? And so you can see I've shown the lab scope here. I'm using a picoscope in this instance. I've got a snap-on scope. I've got the little handheld one-channel scope that I got from AES Wave. There's a lot of different ways to analyze the signal there. This particular HEI output spark tester, is one you can buy at any of your local parts stores. I got one in my toolbox that I've had for 30 years, almost hard to believe that. So, obviously the one you have closest to you is great, but we want to make sure we can really stress the ignition coil, but also we want to be able to analyze the signal.
Well, you kind of answered this next question that was coming up, but you mentioned scope a few times, and the question did come up: do you have to use a lab scope?
You don't have to. There's, again, different ways. For the first 10 years of my career, I didn't have a lab scope. I didn't use it. And so, again, though, once you have a lab scope, you understand and you see how quickly and efficiently I can analyze the entire ignition system by using the low amp current probe and by back probing some of the stuff. So those technicians who have gotten familiar with the lab scope, I don't think will ever go back from it. We don't have to scope every vehicle, but there's a time and place that really helps you hone in and pinpoint the exact problem.
All right, and the last one I've got, because I know you alluded to it just a little bit, but it came through about the same time, so I figure I'll give you another chance to talk to it, which is, can I not just swap the coil from side to side?
Well, way to put me on the spot and make sure my answers are consistent here, if nothing else. So yeah, it's I know a lot of people like to do it. I don't, for two different reasons here. First one being the one I mentioned already. If we've got a short out ignition coil and it's damaged the driver on one circuit, I don't want to swap it, and now that driver is going to damage the new ignition coil. Now again, best practices, once again, if I'm going to recommend replacing the PCM, I'm going to recommend replacing all the ignition coils at that point. They've all got the same amount of sparks thrown out of them for the most likely part and the most amount of wear on them. And so best practice, let's replace all the ignition coils at the same time as the PCM. But if we're not going that route, I'd hate to damage another ignition coil and then you put it back on and now you damage your new PCM. So that's the first reason. The second reason comes back to carbon tracking. On a lot of today's coil-on-plugs, they're down inside the spark plug well on the cylinder head there. We see a lot of carbon transfer from the boot to the spark plug and it shorts it out, creates a misfire. If you've now swapped that to another cylinder, you've just created additional problem on that particular cylinder. So once more, best practice is to replace the coil and replace the spark plug at the same time. So down and dirty, if I'm stuck in the desert somewhere and that's what I got to do, I'm going to swap it. However, I'm not always a fan of those swaptronics. So it looks like you've answered a lot of them, or we've covered quite a few here. So, as we kind of wrap things up, I want to remind everybody, as I did at the beginning, take a look at our Standard Brand YouTube channel. You can look at all of our previous power hours. This one will be posted, the next day or two as well. But we've got a lot of additional information. If you're curious about our coil program, Corey's behind the camera on this one, but quite often he's in front of the camera doing some of the stuff here. And so you can learn more about our program there. Always go to standardbrand.com, look at our topic of the month. You can see some updates there, some great tech articles, catalog lookups, etc. So that's it for me. I look forward to seeing you again. I think next month we're actually going to have Chris back to do some VVT. And then, I'll be back. I know I got some emissions one on tap and a couple other things coming up here. So enjoy the rest of your day.